expression here, we substitute in term of t. So when it's given, so we have to find the r prime t, which is the differentiate for dx dt here is equal to 2t. dy dt is equal to 4t. dz dt is 3t squared. Alright, so we have to plug in inside here. So f here is equal 3, x is t squared plus 1, 3x, y is 2t squared minus 5, z here is t cube minus, alright, then plus 10x is t squared plus 1, right? This is dot r prime. So r prime here, r prime in term of t is equal right, this is right, so this is negative. Okay, so r prime here is equal to 2t, 4t and 3t squared. Alright, so we have 2t, 4t, 3t squared. Okay, so first we have to expand this formula here. So we get 360 squared. 60 squared is 3 times 2, 6 t squared. T squared is 6t to the power of 4 plus 6t squared. Alright, so this one we have to multiply with this component here, so 2t. Okay, then negative 5t cube here, multiply with this one, negative, we get negative 20 t to the power of 4, and here we multiply this one, so we get here 10t, we get 30 t to the power of 4 plus 10 plus 3, okay, 30 t square. Alright, so then what we get here is this here is 12t5 plus 12t3, alright, plus minus 20t4 plus 30t4 plus 30t square. Alright, then we gather all of this, 12t5 and then t4, we get plus 10t4, right, and then we have plus 12t3 and then plus 30t2. So we have 12t5 plus 10t4 plus 12t3 plus 30t2. Okay, so this is question is don't forget, we don't forget the integration here, the integral here, 1 over 2, so is dt here, and t here. Alright, so next what we have to do is we have to evaluate this integral here. So we evaluate this in terms of, so this one is equal to 12t6 over 6 plus 10t5 over 5 plus 12t4 over 4 plus 30t3 over 3. Alright, then we substitute in this limit here, 1 to 2. So can we calculate this? When we replace t is equal to 2, what we get here is, right now, so when we get here is, we calculate it 12, 2 to the power of 6, when t is equal to 2, 2 to the power of 6, we get here is right, 1 to 8. We simplify this first, 1 to here, 4 1 3 and then 10. Alright, so 2 to the power of 6 times 2 is 1 to 8. Then 2 to the power of 5, 2 to the power of 5 times 2 is equal to 64. So here is 1 to 8 plus 64, and then 2 to the power of 4 times 3 equal to 48. So here is 48. So 2 to the power of 3 times 10 is here is 80. Alright, 1 to 8 plus 64 plus 48 plus 80 minus, okay, minus 2 plus 2 plus 3 plus 10. Alright, so what we get here is 1 to 8 plus 64 plus 48 plus 80 is equal to 3 to 0 minus 4 minus 17. So the final answer is 320 minus 17 is 303. So for this work done here is the final answer is 303. Alright, this is the simplest example because the curve, the limit is given here, and also this they are given this curve here. Alright, so the curve equation. So this is considered the simplest example as compared to the previous one. So as you can see here, the solution for the work done is almost similar with the line integral of a scalar vector of the scalar field. Okay, so it's almost similar. The line integral of a vector field is the solution is almost similar with the line integral in a scalar field. Alright, we go to the example number 4. To find the total work done. So this example is also to find the total work done in moving particle in the force given by, so this is the function here. So along the line segment from point A to point B. Alright, so first of all, what you have to do is by picture it. Alright, so let's say this is z exists, z exists here, this is x exists here, right? So this is y exists here. So we know 1 0 0 is somewhere here, point A, 1 0 0, and up to let's say point B is somewhere here, 4 1 2, right? So here is 1 0 0. So first you have to picture, and then second you have to parameterize. So we have learned in the line integral of a scalar field how to parameterize it is by identify from this point, identify the okay, so we have to alright, so this is point A, 1 0 0. So this is point B here for 1 and 2. So if you remember, this 1 minus t is here, 1 minus t, 1 minus t, plus t, plus t, plus t, right? You get here is 40 minus t, here is 3t plus 1, here is t, here is t. Alright, when you try to substitute t is equal to 1, so we get 4 here, right? Then we substitute t is equal to 0, here is 0 0. So when t is equal to 1, we get 4. When t is equal to here is 0 and 0. Alright, next we substitute when t is equal to 1, so we get oh sorry, this is 2t here, sorry, this is 4 and 1, and this is 2, right? So here is 2t. When substitute t is equal to 1, we get 2 here. Alright, so this is how we parameterize, but please remember, after we parameterize, what we have to do is to so let's say we put it in this way, rt equal to 3t plus 1 in x, dy is t and 2t. Alright, so r prime t is equal to dr dt. We get it here is 3, 1 and 2. Am I right? Alright, so next is we have to plug in into this equation here. Alright, so first of all, we know the line integrals is from 0 to 1. So function f is given here. Function f is given z square, but we have to put it in term of t. We have to express this function in term of t, right? In term of t. So how do we express in term of t is by plug in this parameterize here inside inside here, inside this function, right? So let's say so for the x here is 3t plus 1. Okay, so now we have okay, f here is z. We consider z is 2t, right? So you have to do is 2t squared. Alright, am I right? 2t squared and then y squared is equal to here t squared, right? And then z x here is 3t plus 1 squared. So we do the dot product of r prime t is 3, 1, 2. Okay, you clear up until here? So next, what you have to do is you expand square here, and then you multiply by you solve this dot product here. So let's say we have here is 40 squared, right? 40 squared times 3 is equal to 12t squared plus t squared times 1 is equal to t squared plus we have to expand this, but just do it this way first to make you don't confuse yourself, right? After you plug in inside this is equal to 0 to 1. So sorry, this one is square, right? Alright, so expand this equation to squared. That means we get here is 13. This is 2 squared, okay, 13 t squared. Alright, 13t squared. We expand this first. We get is 13t squared plus 3t times 3t times 3t is 9t squared, right? 9t squared plus 6t plus 1. Right, then we multiply by 2. So we get 18t squared plus 12t plus 2 plus 13t squared. So we have here 8. We get, so then 0, 1, 0, 1. What we get here is 13 plus 18t squared. We get 31t squared plus 12t plus 2 dt. Alright, so this is all of dt. So next is this one from 0 to 1. So next we need to what we have to do is to integrate this here, 3 over 3 plus 6t squared, right? Then plus 2t 0 to 1, right? So we get here is 31 over 3. So we get here is 31 over 3 plus 6 plus 2 equals to 8 plus 31 over 3. We get here is 24 plus 31. So the final answer is 53 over 3. So this is the final answer for this for this example number 4. 31, I have to check. I have to 31 over 3 plus 6 plus 2 is equal to, yes, 55 over 3. Alright, so you have to keep practice on the example, keep practice on the tutorial, and try to find another question by yourself in order for you to what we call to get in order for you to get used this integral, the line integral. It's quite maybe you have to do it properly so that you don't have any uh, mistake, any clumsy mistake lah. Alright, so okay, we move on. Alright guys, we go to the last subtopic of the line integral, independent of path. Alright, so the line integral function here is depends on the path C, right? Depend on the path C. So let's say we have point A here, right? And then we travel from point A to point B using this curve. So let's say this is the C prime here, and then we travel it by this way. Here we have C here. So suppose we are two curves starting at the same point, alright, C prime starting at the same point and at the same point here. So this doesn't mean that the curve C and C prime here will give the same value of C. So this means CF dot dr is not equal to C prime F. This is C prime F dot dr. So even though the two paths here is in the same starting point and at the similar starting point. Do you understand? So we have 2 points, so that means we have point A and point B. So when we have 2 points, the path of the C prime and the path of the C here is different. So when the 2 point is different, when we are starting from the same point and end at the other point, even though we take have the similar start and end point, but we take in different path, this will give the difference in f dot in the line integral f dot dr with different path, right? Okay, when is the line integral independent of the path? When? So the line integral of a vector function is said to be path independent if and only if the line integral is equal to 0 whenever C is a closed path. That means let's say we have this point here, this is point A. Alright, so let's say this is a closed path, right? So the point A is the starting point. So when there is a closed path, so the point A is equal to B. Let's say B is the end point. Right? So when we travel along this path, we start at the point A here and we end at the point A. So we have the similar endpoint with the closed path. So that means the integral, the line integral, is independent of the path, where the the curve C here is closed path. Closed path here means the starting point and the end point is exactly on the same point, right? So it's different from this, because let's say we have 2 points here. This is point A and this is point B. Alright, so this point here is not similar to each other, and this point here is we have the start and end point here, so this is not a closed path. So this is not, the line integral is not independent of the path, right? So only if and only if the path, the C, is a closed path, we consider is this line integral is equal to 0. Alright, so F is conservative force field. F is the gradient of a function, so the gradient of function here. So that means when we solve this integrate, we integrate here, f dot drc is equal to c gradient of the function dot dr. So by using the fundamental theorem, we can get f n is minus by f start is equal to 0, right? So this in the next slide we will go further on this definition here. Alright, so the third one is if curl f is equal to 0. So these three definition here will give us the independent of path